So now in this video I thought we would just do a fun little experiment. LEDs here, they are light emitting diodes. They emit light when you put enough voltage and current through them, and if you're not putting current through them, they actually act like little solar cells. So they actually build up a little bit of voltage. We'll look at that. So at the end of the cable for this pocket oscilloscope, we have the alligator clips. I clipped them to jumpers right there, and we'll zoom in and you'll see that when I get a relatively bright light on the LED that we got a little bit of voltage. And just in case you can't see the end there you can see the voltage on there when I get the light on it pretty good. So unfortunately this oscilloscope is not good for measuring it. We'll also look here that it's the long lead, the anode, to the red jumper, short lead, the cathode, to the blue jumper right there. So we're gonna use an op amp here wired as a voltage follower to get a better look at what the voltage of the LED is. So here is a close-up of the LM358. We got the little divot there, and so that is the top there. We got pin 1, 2, 3, 4. That's the ground, the negative supply. We have 5 volts at the rail right now. And then 6, 7, 8. 8 is the positive supply right there. That's what powers the op amp. There's 2 op amps. One on this side, that's the number 2 op amp. We're just going to use the number 1 op amp on this side. So from the output to the inverting input, we have them tied directly together. And when you do that, whatever voltage you give to the non-inverting input right here will be the voltage at the output because of the negative feedback. The op amp does what it can to hold those voltages equal. So it's a pretty simple circuit, the voltage follower for an op amp. I made other videos where we looked at it, and so we're just going to rush through this. So in any case, the oscilloscope now is measuring the voltage in relationship to ground instead of the voltage across the LED directly, and we're going to measure the voltage at the output. And we're going to see something interesting. You can see a voltage built up right there. So that's the voltage with the LED there. And you can see we got a problem if we yank it. It should be 0 volts, but there's still voltage built up at that input. So it's not meant to be floating, these inputs. So in any case, there we have the voltage, but you're going to notice here that it doesn't change when I get light on it. So it changed a little bit right there. Went up a speck. But in any case, this input has a lot more impedance, a lot more resistance than the oscilloscope does. So it's not pulling down the voltage of the LED when it gets darker. So what we're going to do, this is a 10 million ohm resistor, 10 mega ohm. Grabbed it out of this kit. First time I used one of these. And so I just literally pulled out the first one. This time I was kind of surprised. So in any case, we're going to put that parallel to the LED. And remember that the long lead, the anode, is to the inverting input. Short lead, the cathode, to ground right there. So I think those, no, they're not connecting. So in any case, thought we might have had a little short circuit. So there you can see we got less voltage now. We had about a volt before, but now it's lower. And if I get the light on the LED, now the voltage goes up. And if I get farther away, you'll see that it goes down. Let's try widening the beam there so we got less light. So you can see it goes down depending on how much light is falling on the LED. So we have, in a way, a light meter, but it only goes up to about the forward voltage of the LED. For it to conduct is also about the voltage it can produce, but that hardly any current if you get a bright enough light on it. So now really that's it for this video. Just a simple demonstration, get you a little more familiar with electronics, and you'll hear from time to time that LEDs are basically mini solar cells. They are very bad solar cells though. They hardly build up any current. You can see we struggled with the oscilloscope to get a voltage built up there. We needed an amplifier. But there's a lot of amplifier circuits out there, and you may have diodes that the light can fall on the silicone or whatever semiconductor it has that produces a voltage that may be problematic. So you may actually someday have a circuit you troubleshoot because you realize a diode is creating a little bit of voltage and messing things up. So it doesn't happen often, but it does happen. But in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. If you can donate, please do. I have links down below. That would help out the most, but watching videos is very helpful too. I appreciate that. I'll see you in the next video.